Welcome to Brain Vision.
Okay, so for this question, we can determine the time period, frequency, spring constant, amplitude, total energy of a system, maximum speed, and maximum acceleration. So I would like to pick 5 of them out of it, and these 5 physical quantities will be the time period, spring constant, amplitude, total energy of the system, and the maximum speed. So I think the easiest one to start with is amplitude because it's given from the question. Because in the question, it was saying that pull it down 0.12 meter from the equilibrium position, which means that the amplitude is equal to 0.12 meter. And then we can determine the time period, which is equal to the time that was given from the question divided by the numbers, because it was saying that it takes 5 seconds for the object to complete 10 vibrations. Okay, so the time period should be equal to the time you measure over the number of oscillations, which is equal to 5.0 second over 10. And this will give us 0.5 second. And then we can determine the spring constant because time period for vibrational motion is equal to 2 pi times square root m over k. So therefore the spring constant should be equal to t over 2 pi to the power 2 so it's actually m over t over 2 pi to the power 2. Okay, so it should look something like this: m over t over 2 pi to the power 2. And then we know the mass was given as 1.6 kilograms. And we know time period is 0.5 seconds. So over 0.5 seconds over 2 pi to the power 2, which will give us the spring constant is about 252.7 Newton per meter. So since we know the spring constant, so now we can determine the total energy of the system, which is equal to 1/2 Ka squared, which is equal to 1/2 times 252.7 Newton per meter times the amplitude square, which is 0.12 meters squared. And this will give us the total energy is about 1.82 Joule. Now let me see what else is left over. Okay, so now we can determine the maximum speed. So the maximum speed is equal to amplitude times the angular frequency, which is equal to a times 2 pi over omega. I'm sorry, 2 pi over t, my bad. Because angular frequency is equal to 2 pi over time period, which is equal to 0.12 meter times 2 pi over 0.5 seconds. And this will give us the maximum speed is about 1.51 meter per second. And this is the answer for this question.